Let's look at satellites and the different types of satellites that there are. I'm at the AMS website. I'm going to pull off some current satellite images so that way you can compare them. So starting on the main page, here's where you grab your current weather studies. If you had any studies from the previous week, catch it under the previous week's learning files, but I'm going to scroll down, and then here's where all of the new maps are. You've got your surface and then all the surface choices that there are. You got radar and all the radar choices. Here's obviously the satellite. Here would be upper air. We obviously want satellite. And you can see that there's infrared, and then you've got animation. You've got one that's previous and another one that's previous as well. So you got the current one that's out, and then you've got the two standardized ones, which is the 0Z and the 12Z. You have the visible, the latest, and sometimes you'll see the same thing. We'll get a 0Z and a 12Z. In this case, this website gives you the 18Z choice. And then you also have water vapor. Water vapor is another really good one that shows you the water that's in the atmosphere. We're going to look at infrared versus the visible. All I did was grab off of the AMS website the infrared and the visible and the water vapor, and I stuck it in a Word document so it's a little bit easier to see them without having to flip from screen to screen. I can just scroll down, up and down. Now here's a picture of the infrared. You can get, other websites will show you specifically a region. AMS website gives you just the whole country, which is fine. Either one works. Just depends on what you want to look at. So here's the entire country, obviously, a little chunk of it. And you can see on here that it shows the clouds. Infrared is nice because it has one huge advantage. The Earth radiates in the infrared radiation, meaning it constantly gives off this infrared radiation all the time, day and night. Very convenient, seeing how the sun isn't up all the time unless you're at the poles at a certain season. You're going to have the sun go down, and eventually you can't use any of the satellite images unless you have an infrared one, where you have a special instrument on the satellite that detects the infrared radiation being produced by the Earth. You can see that's nice. It has some detail to it, not as much though, which is why it's a huge disadvantage. You can see there's a lot of cloud cover up in the northwest. There you have a huge amount of cloud cover on the east coast. That is the front that had just moved through the Kansas City area just late Thursday into Friday morning, where we had that nice cool down that went along with it, and quite a bit of rainfall we had along with it as well. So that was yesterday, September 20th. It was early morning hours. The front actually moved through, and you see a huge defined front line. So behind it is the clear, cooler air, and the head of it is that more warm and more moist air, which, as you can see, in the form of the clouds. This would be the next storm system that'll be preparing its way on through. And this is September 21st, tomorrow September 22nd, and that would make it one of the equinoxes, which is a neat thing. We have one of the seasonal changes coming through. So that's the infrared. Big plus, get it all the time. One of the huge negatives of an infrared image is it doesn't have as much detail to it. Visible images have a lot of detail. Visible satellite detection is really great. You can see here's that same front, and when you're looking at the infrared, this didn't look quite as clear behind it. And that's because it just doesn't pick up a lot of those clouds. It just doesn't have that ability to catch all the different changes in the heat that's being released, whereas the visible, it's sight. So sight is a little bit better. And you can see there's even more definition. There must be a thunderstorm right about there, where you see the cloud top looks like it's a little puffed upwards. And you can tell that as you go down in Florida, these are more puffy clouds. So a lot more detail in the visible. Again, if we're heading back towards the west, you can see again in the Four Corners region, a lot of detail versus on the infrared where it wasn't as much. I'm going to scroll back up so you can see. Yeah, you can tell there's clouds there, but still not as much detail as you see in the visible. You could tell more cloud types, what they would potentially be in a visible versus you could in an infrared. And again, if you look at this little feature in Georgia, you can't really tell as well that that's what's going on here, that there's a more raised cloud top. You can tell there's the same little hole, or it looks like a hole in it, but not the same. When you're looking at the Great Lakes and the Ohio River Valley, you can see that you can tell there's clouds if you look really close, but obviously a lot more detailed in the visible. So a huge plus for the visible is the detail that you get with it. Obviously the huge minus is it only works when the sun is up. Now with your infrared and with your visible, you can get these in a color image. On the AMS website they do the black and white, which is a little easier to see stuff, but you can get color images as well depending on what website you're on. The black and white is easier to look at. When you're looking at either the infrared or the visible, the darker it is, that means the warmer it is. And so all the ground is going to be the darker, the blackish colors, because that means that it's darker, it's warmer. So stuff closer to the ground is going to have that lighter shading until you get to the ground where it obviously is a lot warmer than stuff that's up in the top part of the atmosphere. So the darker it is, the warmer it is. Or you can look at it in terms of the brighter white the clouds are, the higher the cloud tops, thus the colder the clouds are going to be, because higher up in the atmosphere it's going to be colder. So any of these shadings that are not bright white, but they're kind of that lighter grayish type color, then they're clouds that are closer to the ground. And that's a good way to determine what kind of clouds you're talking about, and maybe how strong a storm is. What it's telling you is that it's a colder cloud top, thus it's more vertically developed. Flipping down to our visible, which makes it even easier, is again the same thing applies. The darker it is, the closer to the ground it is, the whiter it is, the higher up in the atmosphere, and the colder it is. When you're looking at severe weather, it's really helpful to look at a visible satellite, because a lot of times before you actually get the rain falling out of the cloud, obviously the cloud's already there, and what you can end up doing is you can pop here on a visible satellite and catch one of the cloud tops, and you're like, oh look, it's already a bright white speck, and you're like, okay, so there's a severe thunderstorm that's coming, and you have that potential for that to be a severe storm, and you would know that you need to watch that before the rain even started in that area. And again, once you started seeing the rain on the radar, then you can, piece it all together and have a better idea of, where it's moving and that kind of thing. But it's an extremely helpful tool to have, is using the visible. But of course, if you're talking about severe weather in the evening, that doesn't really work if the sun has gone down. And the last thing to look at is the water vapor image. This tells you the water content that's in the atmosphere. And this is the same timestamp and everything as the other two images that I have shown you. So again, you can see that strong cold front that had moved through. Lots of water vapor that was ahead of it. And that's why there was a lot of rainfall that had come with it as well. And you can see that's all along the eastern seaboard. As you head back towards the west, UMKC right about here. And there's not as much water vapor in the atmosphere, which this is a very clear day outside. There's not any clouds outside. It's a very nice, beautiful day with very extremely low humidity, because all that water vapor is obviously moved off to the east coast. Now you can see there's more that's trying to move in as you head more and more towards the west, and then you get a lot more concentration as you get to the Pacific Northwest. But this is the same thing that you're looking at. You're looking at that water content of the atmosphere, what's actually present in the atmosphere. Nice tool to go along with your satellite images, is to see just how much water is available. If the clouds are just getting ready to form, and you can see on the water vapor image, like for example, down here in the Gulf of Mexico, lots of moisture, then you know those clouds are going to be able to develop and maybe get thicker and more abundant as well.